Okay, this video goes with the 6.5 additional practice from Savvas Geometry, Properties of Special Parallelograms. Your assignment, if you want full credit for this one, is to do all the evens. So we'll do some of the evens and a selection of odds too, but not all of them. You need to finish up the ones we don't do. So let's do number 7 and 11 and 1. Let's do 6 and 12. So there's more than this. Let's go down here a little bit more. And let's see. So you got to do evens. It's 14, 16, and 18. So we'll do 16 and 13. So we'll do the asterisk ones, and you need to complete with the others. So let's go back up. Let's see what we got here. So let's see. We do number 1. So we want to find out what AB is. They're giving us some information. Find the stated lengths for this rhombus rounded to the nearest tenth. So it's saying that ABCD is a rhombus. Now, since this is a rhombus, if this is labeled 10, all of these sides are 10s. So let's label that on there. We got a 10 there. This is a 10, and this is a 10. Also, these are right triangles. And these, let's see, these diagonals bisect each other. We got a 53-degree angle. The angles are bisected by the diagonals, and opposite angles are congruent. So those are 53s. And we've got the 90 there. 90 and 53 is 143, which leaves 37 for each one of these. Whoops, 37 and 37. And then all of these are right angles. So see what they want. They want AB. The distance from A to B is 10. Let's say you wanted BCD for number 4. B to C to D, that's going to be 237s. So that's going to be 74. So sometimes the easiest way is to kind of solve the diagram and then use it to answer the questions. It actually saves you a little bit of time sometimes by doing it that way. Let's look at this next set. Okay, we got another rhombus. Now, this mainly deals with the angles. So the key idea with a rhombus, with this rhombus anyway, is that they're playing off on the diagonals being bisectors. So this GK is congruent to KJ. So x plus 9 is going to be equal to 3x plus 1. That's how we can find out the x that goes with this length. And then this minor diagonal is going to bisect angle H. So if half of angle H is 4y minus 8, the other half is going to be 4y minus 8. And these two other angles here at F are going to be 4y minus 8. If G is y plus 4, the other side of G is going to be y plus 4. And both sides of J are going to be y plus 4. And notice that here we have y plus 4. Down here is going to be the same thing as x plus 9. So y plus 4 equals x plus 9. That might be something we might need to use. So let's see what they want. So let's do number 7, HFI. So HFJ. They want to know what this angle is. So let's see how we can do this. We know that these middle angles are 90s, so these are all right triangles. And what can we do here? This has got x's and y's. This has got a y. But notice that these are the same, right? So this is a y plus 4. But it's congruent to the same angle that's x plus 9. If I just basically took this y plus 4 and substituted it in for the x plus 9 part, since they're supposed to be the same thing, now I can do that this triangle here has angles that add up to 180 degrees with a 90-degree angle for the right angle. So we could do 90 plus 4y minus 8 plus y plus 4 equals 180. So let's see, 4y plus y is 5y. 90 take away 8 is 82. Plus 4 is 86. Okay, let's double check the numbers. So we got a plus 4 and a minus 8. So that's a net minus 4. And a 90 take away 4 is 86. We've got a 4y and another y that gives 5 y's. All together they have to be 180, so that's good. So take away 86 from both sides. 5 y's equals 94. Divide both sides by 5. Y is going to be, what, 1? It's 50, 44, 44 left over. Oh, 6. No, it's 4. So y is going to be 18. We give 90. And 4/5 is 0.8. So 18.8 is what we get for y. And let's see, we might be able to find all the angle measures with that. So y take away 4. Now remember, here at J, this we're finding half this angle here when we do the x plus 9 or the y plus 4. So that's going to be 22.8. But this angle here is also going to be 22.8. That's going to give us 45.6. So y plus 4 is going to be 22.8. And this one's also 22.8. This is 22.8. And this is 22.8. Now we can also find out what x plus 9 is, because x plus 9 has to be 22.8. Take away 9 from both sides, x is going to be 13.8. So x is 13.8, y is 18.8, it's 13 again. And we found these angles. Now we got over here, we got to find these angles. All these angles are going to be congruent. So 4y minus 8, 4 times 18.8, take away 8. 4 times 18 is going to be 72. 4 times 0.8 is a 3.2. That's going to be 75.2. And we got to take away 8 from that. So 4 times that's 75.2. Take away 8 is going to be 67.2 for each one of these. We change colors up. So we got 67.2, 67.2, 67.2, and 67.2. So let's look. Okay, so for HFJ, they want this angle right here, 67.2. If we're going to do JK, now the length of JK, we didn't talk about length. JK is this length here. Actually, I messed up here. They're saying that this is x plus 9. So I'm not sure this x plus 9 stuff I just did isn't correct. That goes with the diagonal. I thought they said that this angle is also x plus 9. It's actually this diagonal. So to do JK, which is half this distance here, since the diagonals are perpendicular bisectors of each other, this GK segment is congruent to the KJ segment, so we can actually set those equal to each other. So 3x plus 1 equals x plus 9. And you can solve for x. And then when you plug x back into either side here of this equation, you're going to have the length that they're looking for, which is the half distance length from the end to the midpoint. Okay, let's move on. Let's look at 9, 10, 11, and 12. Let's look at number 11. Okay, find the stated lengths. Let's see what we got. LM. LM is this distance here. What can we do with that? Now, we've got a 26. Now, this is a rectangle. So we got right angles. The diagonals are going to be congruent to each other. The diagonals are going to bisect. So one thing we can do, we can find out what MP and PO are. And MO then is going to be double those. And since LM is this one here, let's see what we can do. 26 with the side. Yeah, basically to figure out what this LM side here is, we really need to kind of deal with this right triangle. Which way do we want to go? Let's go this way. So we're going to deal with this right triangle here. We can figure out what this MO length is by solving for A and plugging it in. That's going to give us the, and since the diagonals are congruent, LN is going to give whatever that number is. That's a hypotenuse. And then we have a leg of the triangle, which is 26. And this LM side that we need to find, we'll call X. And basically we're going to do A squared plus B squared is C squared. Once we find out what the C part is, then we can finish it up. And to find what this hypotenuse is, we need to find the length of the other diagonal since it's congruent. So let me draw this triangle over here as a reference. So this is M, this is N, this is L. Now this length here we need to find is going to be the same as this one. And so we could do 5a minus 7 equals 2a plus 8. Since these diagonals bisect each other, each one of these sections is congruent. Take away 2 a's and add 7. You get 3a is equal to 15, which means a is equal to 5, which means that this total length here is going to be 25. For half the length is going to be 25 take away 7, which is 18. And the other half is going to be 18. And so totally the length is going to be 36. So that's a 36. Now they're telling us this other one is a 26. And that's the one we need to find. Here's our right angle. A squared plus B squared is C squared. So ultimately, X is going to be the square root of the hypotenuse squared minus the leg squared. So we got 36 squared minus 26 squared, and we need to take the square root of that. Now, in case you haven't done square roots for a while, you can't simplify this the way that they are. You can't just do 36 take away 26. You actually have to multiply it out, multiply the other one out, find the difference, then take the square root. Okay, so the square root of 36 squared minus 26 squared is going to be square root of 620. And 620, when you take the square root, you get 24.899. So that's going to round off to 24 or 24.9 for this length X, which is our LM, 24.9. And they're not giving us any units, so don't need centimeters or anything like that. Let's look at number 12. They want to find the angle NMO. NMO, which is this angle right here. They want us to find this angle measure. So let's look, see what we got. These diagonals all bisect each other. So each one of these sections is congruent. That gives us an isosceles triangle. It actually gives us two pairs of isosceles triangles made by the diagonals. These base angles have to be congruent. Also, this rectangle is a parallelogram, so we have alternate interior angles congruent. So if we look at this Z here, this 24 is the same as this angle up here. So angle PNM is a 24. And because this top angle is isosceles, this angle PMN also needs to be 24. Now they want you to find NMO, which is another way of saying the same angle measure that I just said. So that's how you can do number 12. Okay, let's look here at number 13. Find the missing values. Now here we have a square. So all these sides are congruent in the square, so we can pretty easily figure out what K is. Since these two sides have to be congruent, we can set the expressions equal to each other. Okay, take away 7 from both sides, take away 3 from both sides, minus K equals minus 9. Opposite of both, K equals 9, which means that we have 18 plus 7, which is 25. So each one of these sides is a 25. You can check it. 3 times 9, take away 2, also is 25. They want to find RV for 13. R to V is this half distance in here. So let's see what we could do with that. These two segments are congruent. We could call those X's. And this is a 25. Here's a right angle. So we have A squared plus B squared is equal to C squared. So really, in effect, we're using the Pythagorean theorem on a triangle that looks like this to figure out what this X part is. And that's RV, which is what they want us to find. So X squared plus X squared equals 25 squared, which is 625. We get 2x squared is equal to 625. Divide both sides by 2. X squared is going to be 625 divided by 2, and take the square root of that. Let's see what we get. Okay, so 625 divided by 2 is 312.5. On the calculator, when I do the square root of 312.5, I get 17.677, which rounds off to 17.7. So this length is 17.7, which is the RV length that they're asking us to find, 17.7. For 14, you want to find SU. So SU is actually going to be double what we just found. And you need to find the area of RSTU. So the area of this is basically going to be 25 times 25, which is the 625. Okay, let's set up number 18. She needs to cut rhombus-sized mirrors, rhombus-shaped mirrors for cars. The lower right corner is 98 degrees. Did she correctly cut the mirror shown? Okay, so this corner is supposed to be 98, which means this other corner should be 98. Now, altogether, these need to add to 360, and these have to be congruent. So 98 and 98 is 196, 196 rather. And altogether, these have to be 360. So 360 take away 196 is 164, I believe. 64, yeah, 164. And both of these angles are congruent and make up the 164. That gives us 82. So this angle is 82. And double the 41 also gives us 82. Because these diagonals bisect. Half of 82, 41, it works out. So yes, she did do it correctly. In words, you need to explain.